Hat to bring up a native of Barcelona who's come back home. So let's give him a nice come on home, warm welcome. Please welcome to the stage Ignacio Riesgo.
Thank you so much, David. Thank you so much, everyone. My name is Ignacio, and yes, I am a native from here, from Spain, so glad to be back. So let me first start with what we are going to do in the next 30 minutes. And this is a good summary. It's understanding the code behind the products. So basically, it's about what do we do is understanding the products that we have at Red Hat. That's the objective of today. But more importantly, how you can use your products in order to get you enabled. And specifically, we are going to put focus on the AI technologies. As you know, Red Hat has a huge portfolio. We are going to go through briefly, but the main objective is going to go and demo specific products that we have for AI. For that, I will have Natale to help me doing those two demos, and we are going to demo both Developer Hub and AI OpenShift AI. But first, let me make the connection with what yesterday we did with the intro keynote. This was by Dinesh, and this was the intro. And you can see here that the last of the columns, the last line, Hybrid Cloud AI Tools, is based on Red Hat OpenShift AI. That means that the baseline of everything that we put on top of that, also at IBM, is Red Hat OpenShift AI. This is exactly what we will go through during the session. And by the way, there is another important element that is the connection with open source. And we will talk also a bit about that. So key questions that we are going to address today. First of all, what is the OS that we need to use? What is the programming languages? And more importantly, what are the developer tools that we need to use in order to start creating what we call AI-enabled apps? So first of all, infrastructure. We believe that AI needs hybrid cloud. And why? Two reasons. First, because workloads can be very, very big. Second, because you need to have access to hardware accelerators. And third, because you need to have access to compute on demand. So hybrid cloud, and not only is something that it's coming, but it's something that it's already there. I just want to bring a couple of data points. The first one is IDC survey of 200 US-based 1 billion companies. Already 93% of the companies are using multiple infrastructure clouds, and 81% are already using public clouds and one or more private and dedicated clouds. So it's not something that it's coming, it's something that it's already here. The second is what do you need for OS is Red Hat Enterprise Linux. Another data point is not that Linux is already running 90% of the public cloud workloads. And if you go to containers, it's already higher with 96% of total running on Linux. For that, we have Red Hat Enterprise Linux. It's our own version. It's the Red Hat version of Enterprise Linux, based obviously on the open source project. But what we offer with Red Hat Enterprise Linux, what we call RHEL, is 10-year lifecycle. You can upgrade on your schedule, and 9.3 is our latest release. And by the way, you can adopt the new features when do you need. On top of that, you have Kubernetes and OpenShift. What is Kubernetes and OpenShift? It's a platform to run your applications. OpenShift is the foundation from development to production for those applications to run the business. Obviously, again, and you can see this as a pattern. What happens is, mainly at Red Hat, what we do is we take open source projects, we elaborate on top of that, and we create our own version enterprise level for those open source projects. In this case, we do it for OpenShift. And let me go a bit deeper on the different flavors of OpenShift. You have first line, what we talk about the infrastructure with physical, virtual, private cloud, public cloud, or edge. Then on top of that, you have the line of Linux, that is the OS. On top of that, you have the first, you can see in the first OpenShift Kubernetes engine, that is when you put Linux plus Kubernetes and cluster services. That is if you only need to manage Kubernetes, things like over-the-air, networking, ingress, storage, monitoring, etc. Just the basic version of managing Kubernetes. Then, if you also need to incorporate developer services, DevOps services, like service mesh, serverless, GitOps, tracing, loop management, cost management, etc., then you have another version called Container Platform. And then on top of that, if you want also advanced management and security, then is when you put OpenShift Platform Plus. You can run all of this in all the different vendors, AWS, Azure, IBM, or Google Cloud. And that is the basic infrastructure for OpenShift. So we start with open source. OpenShift is the line for cloud computing and automation, and the critical question is, okay, what do I need to do in order to run artificial intelligence and incorporate artificial intelligence and machine learning in my apps? Two things. First, you create intelligence. Second, you connect that intelligence with your app. Let's go through the first. We have here OpenShift, that is the basic infrastructure. What do we put in top? Three things: application foundations, developer services, and OpenShift AI. Those three lines, we are going to go through first, that is the previous box. Application foundations, the first box, is a comprehensive set of components to modernize and accelerate application development. Here, probably you have a number of developers that are still using COBOL or still using Java or still using those, a number of old technologies that they are trying to modernize. For that is application foundations. It's a set of tools to accelerate and to modernize those applications. You can use runtime, single sign-on, migration, enterprise integration, etc. And you can build, deploy, and manage applications seamlessly across hybrid cloud. But we are not going to demo that part. We are going to demo the other two boxes, because again, we want to put the focus on AI today. Let's go to the OpenShift AI. Why OpenShift AI? You know pretty well. The rise of generative AI, with 80% of enterprises will have generative AI applications. So for that, last summit, we present Red Hat OpenShift AI. And this is Red Hat OpenShift AI. It's an integrated platform for building, training, tuning, deploying, and monitoring AI-enabled applications. With this, we create a connection with the... Normally, we were talking to developers and DevOps teams. Now we are making with AI the connection with the data scientist team. What are the features? You have model development, model serving, monitoring, pipelines, distributed workloads, and obviously responsible AI to find and fixing bias. But instead of doing this and going in detail, I prefer to have Natale to present OpenShift AI on top of OpenShift. Natale?
Thanks, Ignacio. Hey, good morning, everyone. It's a pleasure to be here. This is a second TechXchange I'm attending. It's terrific. What I would like to show you now, it's a live demo with all the consequences of live demos to show you all those products in action. Let me start with a real-world use case. Let's imagine we're in a company like this one, and we're a group of data scientists, app developer, automation engineer. We need to be enable on a project. As a data scientist, the first step you really do is, start from your writing a model, testing this model, and deploying this model. So let me show you OpenShift AI. Was introduced by Ignacio, and also OpenShift AI is a Red Hat product made in collaboration with IBM Research to introduce several open source projects like Codeflare and then KKit and then TGIS. There are multiple open source projects that combine many standards that give you the power to have tuning, training, and deployment of models. In this flow, let me start with a generative AI project. We want to create some service that create images, and we want to use this open source project from Hugging Face. There's a great collaboration between IBM and Hugging Face and also Red Hat, and you can use Hugging Face in OpenShift AI with all the open source model. So I want to use this model. This is Stable Diffusion. It's able to generate some good images like this one. And what I wanted to do as a data scientist, I wanted to start my journey in OpenShift AI. I have several services that I can use. I'm going to use this one, Jupyter Notebook, as a service. And I can create a new data science project. Now, when you create a data science project, this means that OpenShift AI gives you some tools that you need and that you can consume to create your models. For sure, you have your workbench. So this is a Jupyter Notebook instance with all the libraries and dependencies you need. We're going to use this model from Hugging Face. We need PyTorch, we need TensorBoard, we need support for Kafka. Anything is already there, and you have your quota and your memory, your CPU. But of course, we need also storage, right? And this comes handy with OpenShift AI. You have the ability to connect ODF, our software-defined storage, and you can have the storage attached on any bucket attached to save your model. And also, you have the ability to automate the model building. Once you write your notebook, your Jupyter notebook, then you want to automate all the stuff. And it's doable with the OpenShift AI pipeline, which are based on an open source project called Kubeflow and using another open source project called Tecton. And last but not least, you have the ability to serve this model as an inference API with some serving runtime. You can use, in this case, Triton. You can use OpenVino. There are many things that you can use. So it's a kind of a toolkit that connects multiple things. And let me start the journey with using this model, downloading this model from Hugging Face. And when you click here, when you open the workbench, you're going to go into a Jupyter notebook. And what we're going to do today now is trying this model, downloading this model in the notebook, and just trying it out. And let me try to generate a picture of a dog, like I was doing in the page. The model here is just downloaded on this container containing Jupyter, and as you can see, it's a nice dog. But it's not the dog I want. Let me present you Teddy. Teddy is a big Red Dot fan, as you can see from his It's Beautiful hat. And I want to generate picture of Teddy. How can I do that? Well, let me try invoking the model as is. The model has no knowledge, right, about Teddy or Red Dot. So if I try this prompt, this is a nice puppy, but it's not Teddy really, right? I need to train this model. How can I do that training? Well, I can start doing the fine-tuning of the model on OpenShift AI. I have all the dependencies that I need. I have, this, of course, the hardware support that I need. And I need to do the training. And the training, it's based on a data set that I need to load. So in this case, I'm loading 20 pictures of Teddy in a S3 bucket, and then I give to my training job this as input. Of course, this takes kind of 20 minutes. I'm not going this live, but I wanted to show you that once you train the model, you export the model in an open format like ONNX. So it's ready to be served and consumed. And once the model is on some storage with the ONNX format, you can invoke it with an ONNX runtime. If I invoke it from here, you can see this is Teddy in a beautiful house. So the model now, the Stable Diffusion, is working and recognizes Teddy. This is just manual, no? As a data scientist, I write the code and everything is fine. How about I need to automate all? Once I wrote the code, I want to automate everything. Here's the power of OpenShift AI. I can define a pipeline in the notebook, and when I click here, there's a one-to-one mapping between the notebook and OpenShift AI pipelines. That remember is Kubeflow under the hood, and this is running a pipeline, and which is downloading the data, fine-tuning it, generating samples, and then exporting the model in the ONNX format. I already run this. This takes a couple of minutes, right? I just wanted to show you that when it's finished, the model is in the storage, and it's ready to be served. How can we serve the model? Well, we can use the model serving part, which is another component on OpenShift AI. As you can see here, my project text-to-image is served with the Triton runtime, and there's an internal service. This is an OpenShift cluster. This is an internal network, and I can decide the protocol, is it REST or gRPC. I'm going to use gRPC here. So this model now is exposed as an inference API once the pipeline is finished. First of all, I'm going to try it out from the notebook, and then I can deploy it for an app to be consumed from an application. But as a data scientist, let me try the remote procedure call. I'm doing my notebook. I'm doing my connection to the local server. I'm using model mesh deployed in this OpenShift cluster. This is bunch of code. And let me try this prompt. A photo of Red Dot dog on the beach, so it's also context aware. I'll do it live here for you. So I'm going to try the inference with 50 samples. It takes it's a little bit slower because now I'm using networking. It's not loaded from the disk. I'm just using remote calls on the network. But if that works, then it's ready to be served as an API outside OpenShift AI. I can write an app that consumes the model, and this app can be exposed for test. And this is our second demo we'll do later. But let me show you now Red Hat Teddy that hopefully went on the beautiful beach of Barcelona. Here we are. So, the model works, it's context aware, it has its training, and now it's ready to be exposed and served for an application. Back to you, Ignacio.
Perfect. Thank you so much, Natale. So we have now Teddy on the beach with the models, and we can go back to the slides, please. And the second problem that we want to go through is how we incorporate all of this in our normal developer flow. So we went through the first demo, that is the OpenShift AI, and now we are going to the second one, that is Developer Hub. And why Developer Hub? Because Developer Hub is right now trying to address the main problem that most of the developer teams are addressing. That is the cognitive load. The challenge is quite simple, is just too much. Normally, when we talk with developers, the main feedback that we are receiving is, give me a break, tell me exactly the tools that I need to use, please keep it simple, and make me productive as soon as possible. Because right now, the problem is it's just too complex, it's just too much. In fact, Gartner predicts that 75% of the companies will establish platform teams for application delivery. So in order to address that, we go to that box in the middle that is OpenShift Developer Services. And in OpenShift Developer Services, we have a number of different services. It's not only the first one, that is Developer Hub, that is the one that we will go through today, but we have also other developer services, like Trusted Software Supply Chain, addressing also threats in security, or improving the developer desktop experience with Podman Desktop. Probably you know. That is a product that is also complementing with Docker, or Red Hat Migration Services, or IDE tools, or Service Interconnect. All of these products are addressing developer services. So you remember the first box was more focused on the products that are important for the applications. These products are more focused on products that are relevant for developers. In fact, from all these products, we are going to only talk about the first one, that is Developer Hub. That is what we want to do the demo. Developer Hub started as another connected with another open source project, and this case is Backstage. For those of you that don't know, Backstage was started by Spotify. Spotify was experiencing this problem that is, okay guys, when I start, what the problem was, a lot of developers join the company and they don't know what to do. So they start creating this platform, enabling the developers in order to say, these are the tools that you need to start, these are the models, and then what happens is they make it available, they create a CNCF project, and that project was approved, and right now all those tools are part of Backstage. And what we do is, on top of Backstage, what we do is we create a product that is Developer Hub, that is also working on top of OpenShift, and is facilitating. And with that, let me show you, Natale, let's see Developer Hub.
Thanks, Ignacio. Let me come back to our flow. Now, we are this same company. The data scientists created a model using GenAI. We are an open source model. We were able to fine-tune the model and serve the model to be consumed from an app. Now, those folks are also app developers, and they need to be onboarded on a new project to create this intelligent app. So how do we reduce the cognitive load, not to avoid, learning about AI and programming languages and framework? We believe the answer is Developer Hub. Developer Hub, which is the product behind Backstage, is a single pane of glass where you have everything that you need in this place. What I mean is that you can, as a developer, you can log in with one of your authentication system, and you are being onboarded in the system. Then imagine we need to do this application, we need to learn a bit of technology about, we want to do this app with Python using some, creating an API, consuming an API, and then we need to use some, do this Gen AI application in Python. We need to learn about those technology beforehand. It's also very cool understanding if you are new in a company, what the company is doing with this tech radar feature. You can see the programming languages in adoption, but also those one not used anymore. So has a cool feature like learning path, tech radar, but the most important part, I think, it's this one, is the golden path templates. The golden path templates are opinionated way to scaffold a new project from scratch or from some skeleton. In this case, the developer hub comes with some templates, like a popular one, like if you want to create a Go application, Node.js, Java, either Ansible job template, anything can be scaffolded. For this particular demo, I created this template, and the template is scaffolding me a Python application which is able to consume that app. So if we go back to the analogy, I need to create this application. I learn about the technology, and I want to consume this API. I have a list in Developer Hub. I have a list of the API exposed, like this one, and I can click. I can see all the documentation. I can see who is consuming this application. I can see, for instance, the spec of the application, all the parameter. I can try the API beforehand, no, right? Now I need to create really the code to consume this app. I can start from scratch, but I need to create a repository. I need to create everything. How about reducing this cognitive load? Well, you use these golden path templates. Those comes with a form with input that you can pre-fill. Something is pre-filled, something no. So let me create this application in this cluster I'm connected to. I'm referring to the inference API that we exposed before, so I can use those as a parameter. This is me, and you know, all those parameters are optional, or you can make it mandatory, up to you. And I'm saving the container image representing this application in the same cluster. When you hit create, what happens under the hood is that Developer Hub is using its API to create repository on your server, like in this case is GitHub, but it can be GitLab, Bitbucket, whatever. It will scaffold a complete skeleton of the project. And I'm going to show you what it means. You have an overview of your own project started from scratch, from a skeleton. You have your source code here. If you open, this is the app, the Python app with some basic code. But not only that, if you are familiar with DevOps, GitOps, this is also generating the automation to deploy the app in the cluster. This takes some minutes to finish to complete, but I wanted to show you what this means, scaffolding a project from scratch of this level in Developer Hub. So let me go to one project I already created beforehand, right? So we don't wait of the pipeline to finish, because I want to show you what you have there when you scaffold everything. First of all, you have an automation that compile the application and then create a container image and push this container image into a registry. This is a plugin that is one of the core plugins that Red Hat is supporting into Developer Hub. This is the pipeline plugin. Then we have a GitOps plugin, which is able to deploy your app in one or multiple clusters. And there's a one-to-one mapping between the Developer Hub, your cluster, in this case is an OpenShift cluster, Argo CD to deploy everything. And also, any tabs that you can see here, it's a plugin. You have all the info from Kubernetes. You have the info of which API you are consuming. So you don't have to be a data scientist. You don't have to be a Kubernetes hacker to scaffold your first app. It's all done. And you know what? It's also automatically deployed for your first run. You can see the application up and running. You can either code directly from here. I'm going to show you this. This is really cool. This starts an in-browser IDE that lets you code with IntelliJ or Visual Studio Code. This is my Python code. I have my Python terminal. So I can code from here. I can concatenate. This will restart all the automation. So all the cognitive load, it's avoided in this case. And I want to show you this application in the target cluster. So we can see that up and running. And this app is, as we discussed, is consuming that inference API we were talking about before. So if you're not familiar with OpenShift, this is OpenShift, which is a Red Hat Kubernetes Enterprise Kubernetes cluster. And this is the application running scaffolded by Developer Hub from scratch. So I can test it out with you live because the model is serving, the application is serving. And I'm going to send Teddy with this prompt. Let's send Teddy in Barcelona in front of Sagrada Familia. Let's see what happened. This is all live, of course, and now the app is invoking that inference API we are serving with OpenShift AI. As a developer, I had avoided the complexity of knowing all those things. I was studying the API spec. I was having my Python code snippet. I was just coding, and now I can see that I can use a generative AI model at ease that also the data scientist was able to create, consume, download, fine-tune at ease with OpenShift AI. So let me show you, Teddy. Well, yeah, the hat is not red as it should be, but this is an AI hallucination, right? But you know, this is one of the attempts. I think I also did an attempt before, and this was working better. So this means we need to train again the model because the model is sending a yellow hat, but it is working. It's generating picture of Teddy, context aware, and it's using the stable diffusion, but also with the data set that we're provided. So that was a really funny, simple demo to show you how to have a cohesive, connected developer experience between data scientist, automation engineer, and application developer. Thanks, Ignacio. Back to you.
Perfect. Thank you so much, Natale. Okay, love to see Teddy here in front of Sagrada Familia. So with that, we put all the pieces together. If I try to summarize what is the final outcome, this would be the technical roadmap. If you just need to use Kubernetes, then OpenShift is your option. And then on top of that, you put those three boxes: application foundations, developer services with Developer Hub, and then OpenShift AI if you need to incorporate or create AI-enabled applications. We just want to end with part of what we do. Both Natale and the rest of the team that we work with doing developer advocacy, they also write books. And in fact, this is one of those books. We create the book Developer Portals with 3 of our developer advocates. You can download for free in order to learn everything that Natale has been going through. So we invite you, not only that, to download this, but also the rest of the books that we produce in order to talk and to teach these technologies. And with that, we just want to thank you, David, and we are just 1 minute.